Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P16E8 indicates a problem with the communication between the Powertrain Control Module (PCM) and the shutter grille's local interconnect network (LIN) system. The shutter grille is a crucial component located at the front of the vehicle, designed to optimize airflow and improve engine efficiency. This grille operates electronically, and any communication error can impede its functionality, potentially affecting engine performance and fuel efficiency. When the vehicle initiates communication with the components, the inability to receive or send signals correctly results in this DTC being logged. In the case of P16E8, you may find an illuminated check engine light, accompanied by a reduction in performance features associated with airflow management. Understanding DTC P16E8 is vital for effective troubleshooting that can restore the normal function of the vehicle. The error description for DTC P16E8 signifies a LIN communication failure with the shutter grille. The local interconnect network, LIN, is a single-wire serial communication protocol used in automotive applications to connect lower-speed devices. It plays a critical role in facilitating communication between the PCM and the shutter grille. Located at the front of the vehicle, the shutter grille adjusts airflow to optimize engine cooling and aerodynamics. A failure in this communication can result in improper function of the shutter grille, potentially leading to performance issues. This situation requires the technician's attention to ensure that all components involved in the communication line are functioning properly, and to conduct thorough checks to pinpoint the failure source. Several possible causes may lead to DTC P16E8. The first common issue could be poor electrical connections, which occur when connections between the shutter grille and the PCM are compromised. This may be due to corrosion, dirt, or manufacturing defects. Loose terminals can also significantly impair communication, rendering the electrical signals between components intermittent. In addition, wiring faults, such as shorts or opens in the LIN wires connected to the shutter grille, could disrupt communication entirely. Other issues, such as a malfunctioning shutter grille motor or PCM, can contribute to the failure also. Identifying and rectifying these issues is essential before proceeding further in repairs. Symptoms associated with DTC P16E8 can greatly impact the vehicle's performance. The most immediate indicator is the illumination of the check engine light on the dashboard, which alerts the driver to a problem that needs attention. Additionally, the vehicle may experience reduced engine performance, resulting from the impaired function of the shutter grille that may fail to open or close as required, affecting airflow and cooling efficiency. Furthermore, drivers may notice symptoms related to airflow management, leading to overheating or inadequate engine cooling. Identifying these symptoms early on is vital to avoid further complications and repair costs. In the first step of troubleshooting for DTC P16E8, the technician must start by turning the ignition to the on position. This enables the vehicle's electronic systems and allows communication with the engine control unit. Following this, it is essential to clear the diagnostic trouble code using the Honda Diagnostic System, HDS. Clearing the DTC resets the system and allows for new codes to be recorded during testing. After clearing, the technician should turn the vehicle back to the off or lock mode before switching it back to on once again. Waiting for about 10 seconds, the technician will then need to check for any new pending or confirmed DTCs using the HDS to verify if P16E8 is still indicated. In troubleshooting step 2, the technician needs to check for any pending or confirmed diagnostic trouble codes using the Honda Diagnostic System. the system will display whether DTC P16E8 is still present. If P16E8 persists, further diagnosis is required. However, if it is not indicated, it suggests that the issue might be intermittent, and thus the overall system could be functioning correctly at that moment. In such cases, it's prudent to inspect the vehicle for any poor connections or loose terminals around the shutter grille and the PCM to ensure that all connections are secure. If the DTC was recorded in the onboard snapshot, it is advisable to attempt to reproduce the failure while observing similar conditions. Step 3 of the troubleshooting process involves another round of diagnostic checks via the Honda diagnostic system. Here, the technician will once again check for any DTCs, specifically for P16E8, indicating a PGM-FI-ACG LIN communication error. If this DTC is also recognized by the system, it implies the need to progress to Step 4 for further evaluation of LIN-related issues. If P16E8 is not present, the technician will then move on to Step 3 for further diagnostics regarding other potential errors, such as P16E3, which points to a battery sensor communication error. These specific checks help to isolate the fault further and identify the various components that could be impacting the LIN communication system. In Step 4, the troubleshooting focus shifts toward identifying potential failures in the LIN communication with the battery sensor. The technician should start by turning the vehicle to the off or lock mode to ensure safety during the disconnection process. Following this, the technician must disconnect the upper and lower connectors of the shutter grille, which are related to the LIN system. Once disconnected, checking for continuity between respective test points becomes critical. This specific continuity check assesses the connection between the shutter grille connector and the vehicle's body ground. Confirming continuity ensures there are no open wires, allowing troubleshooting progress toward further diagnosing the underlying cause related to DTC P16E8. In Step 5, the next logical action is to jump the SCS, Service Check Signal line, using the Honda diagnostic system. This is crucial for testing if communication can be established under controlled conditions. Afterward, the technician will need to wait more than a minute before checking for continuity between the shutter grille and body ground, interrupting the circuit by disconnecting various connectors sequentially, namely the PCM connector, alternator connector, and battery sensor connector. The primary purpose here is to determine if continuity is lost when one of these connectors is disrupted, which would suggest that the wiring related to the LIN communications is intact. If continuity is maintained, it indicates that a short within the LIN wiring must be researched further. In Step 6, after previously checking the connections and continuity, the technician will reconnect the shutter grille's upper 4P connector, but will disconnect the alternator 1P connector this time. It is important to check continuity between specific test points as previously done. Under the vehicle's off condition, this determination seeks to match the continuity of the alternator connector with body ground. If continuity exists, this indicates the shutter grille's upper component is likely the source of the issue and should be replaced. If not, further checks are needed on the lower shutter grille. In the 7th step, following the previous continuity tests, the technician reconnects the shutter grille's lower 4P connector to allow for further diagnostics. Next, the technician will repeat the check for continuity, ensuring that the alternator is still disconnected. If continuity can be verified again, it may warrant replacement of the shutter grille's lower assembly. However, if continuity does not exist, your focus should turn back to potential issues with the LIN communications. Understanding how both sections communicate is vital for isolating the potential fault leading to DTC P16E8. At this point in the process, Step 8 requires the technician to jump the SCS line with the HDS and wait for more than 1 minute. This method ensures that the communication line is assessed reliably under controlled conditions. Disconnecting both the shutter grille connectors and the PCM connector B allows for continuity checks. The core goal here is to see if there is continuity between the shutter grille's upper-lower connector terminal and the PCM, which directly examines the LIN communication circuit. If continuity persists, it indicates that the LIN wiring is functioning correctly, perhaps requiring a PCM substitution or another deeper diagnosis. If continuity is interrupted, a wire open condition likely exists. In Step 9, repeating the approach from before, the technician will turn the vehicle off or to lock mode to commence the next phase of troubleshooting. Disconnecting the shutter grille's connectors is again important before proceeding with continuity checks. This step gives insight into whether the communication line from the shutter grille to body ground is intact. If continuity is confirmed here, the technician progresses to shorted wire checks on the LIN battery sensor line. If continuity does not exist, further probing into wire conditions and physical damage may reveal the failure source. In this 10th step, the technician will take necessary precautions by jumping the SCS line once more, rechecking continuity, and connecting or disconnecting connectors sequentially as needed. This helps determine if continuity vanishes when each connector is interrupted, helping to isolate if the LIN wiring for battery sensors is functioning properly. Should the following steps confirm that the LIN wiring is intact, it's necessary to assess which component caused any interruptions. This testing procedure could lead to the replacement of components that may have interrupted connectivity without affecting the overall LIN communication network. As we approach Step 11 in this troubleshooting process, the technician reconnects the shutter grille's upper 4P connector while disconnecting the 2P connector of the battery sensor. This step aims to check for continuity again and determine if the shutter grille's upper section is functioning efficiently. Performing continuity testing will help unveil whether these wiring and terminals are transmitting correctly or if they need replacement. If continuity is confirmed, it suggests the shutter grille may need replacing, as earlier sessions have demonstrated ongoing issues with the LIN communication, particularly from the battery sensor wiring. Following the series of checks, Step 12 will have the technician reconnect the shutter grille's lower 4P connector while performing continuity checks. This assessment targets the condition of the lower circuit while the battery sensor connector remains disconnected, helping to isolate any issues that may be persisting below. A continuity check during this step serves as a deterministic assessment for the need to replace either the shutter grille's upper or lower unit based on the outcomes. If issues continue to manifest, further examination into wiring issues in the LIN communication system becomes necessary. In the 13th troubleshooting step, the SCS line is again jumped with the HDS tool. The effective management of this connection allows you to determine the continuity state once more. Disconnecting the necessary connectors, such as PCM connector B, will facilitate checks for open circuits in the LIN wiring leading from the PCM to the shutter grille. This method unveils whether there are complications along the wiring structure or at the connection points that could lead to failures present in DTC P16E8. The outcome will help inform you if replacing the shutter grille or further researching other components is warranted, provided the circuits behave as expected. In Step 14, the initial action requires the technician to ensure that the vehicle is turned to off mode to safely perform electrical diagnostics. The next step entails checking two specific fuses: fuse number A23 for the upper shutter grille and fuse number A22 for the lower shutter grille. If the technician confirms the fuses are intact, we progress to check for other potential faults in the LIN communication line. Conversely, if either fuse is found blown, it's critical to investigate wiring for shorts in their respective circuits, and replacement of the damaged fuses will be necessary. Understanding fuse integrity is crucial, as a blown fuse often serves as a primary indicator of further electrical issues needing resolution. Step 15 involves checking the voltage between specified test points while having disconnected the shutter grille connectors. This phase is vital in diagnosing potential faults with the LIN communication line. The technician assesses whether there is battery voltage present between test points, specifically related to the shutter grille operation. If voltage is present, it indicates the circuit is functioning and allows the technician to progress to further detailed diagnostics. Alternatively, the absence of voltage may signify open wiring conditions either along the communication paths or damaged terminals, necessitating repairs as per the findings earlier. In Step 16, there is a clear focus on checking for battery voltage presence between the specified test points for testing ground wires. With the shutter grille connected, establishing the presence of voltage at test points is pivotal in identifying the state of the ground wire between the shutter grille and body. If battery voltage is observed, it may indicate the harmless operation of the corresponding wiring system. Nevertheless, absence of voltage here signifies open circuit issues within that line. Depending on voltage checks, targeted repairs can then be applied, assuring effective communication pathways within the electrical systems. In the final step, the technician will perform another jump of the SCS line and continuity checks between the relevant components. This reaffirms whether the LIN battery sensor wiring is functioning correctly, specifically between the PCM and the shutter grille. The procedure aims to confirm functionality through careful monitoring of continuity and voltage. If continuity exists, it suggests the wiring is intact, but further diagnostics may require pursuing PCM replacement or other complications. In contrast, discovering an open circuit prompts immediate repair actions to ensure effective communication once more. Following these steps insightfully determines the exact causes of the DTC P16E8 and provides a comprehensive path to resolution. After completing the thorough troubleshooting process for DTC P16E8, it is critical to confirm that the repairs have resolved the issue effectively. The technician should use the Honda Diagnostic System HDS to recheck for any new DTC codes. This is essential for confirming that the previously logged error code has been cleared and that no new issues have emerged. Additionally, the technician must verify the functionality of the shutter grille by observing its operation while the vehicle is in motion or during an idle state. Lastly, ensuring that all connections related to the LIN communication are secure becomes paramount for preventing future operational failures. Completing these steps ensures a holistic approach to wrapping up any repairs made. To avoid future issues related to DTC P16E8, preventive maintenance plays a vital role in sustaining the vehicle's performance. Regular inspection of electrical connections, specifically around the shutter grille and PCM, helps catch any signs of wear or corrosion before they lead to communication errors. Keeping connectors clean and free from contaminants ensures a reliable connection between components, allowing the LIN system to function as intended. Additionally, routinely monitoring the vehicle for any newly generated DTCs provides early warnings of potential problems, facilitating timely interventions. By incorporating these practices into regular vehicle maintenance, the likelihood of encountering DTC P16E8 or similar issues in the future can be significantly minimized. In conclusion, understanding DTC P16E8, which points to a communication error between the shutter grille and PCM, is essential for maintaining optimal vehicle performance. Following a meticulous troubleshooting process allows technicians to accurately diagnose and resolve the underlying causes effectively. Awareness of possible symptoms leads to quicker identifications, while preventive maintenance practices can secure the longevity of electrical systems. In navigating this DTC, it becomes clear that systemic checks and awareness of all components involved are crucial for proper function, reinforcing a comprehensive approach to Honda vehicle troubleshooting and repairs. Please like and subscribe to the channel. See you next time.